Welcome to Geometry for AP. We're going to do a radicals review today, going over how to simplify radicals, how to multiply radicals, and how to divide or rationalize the denominator for radicals. This is a list of perfect squares. It runs to, this is 18, and so 19 squared is 361, and 20 squared is 400. And having this list on your paper is a good thing to have, so you might want to pause the video and write this list of perfect squares down. So if you take the square root of 361, you get the number 19. All right, and so this will help us when we're starting to simplify radicals and work our way through those. So some of our first examples here are like we have the square root of 27. Okay, if you wanted to simplify the square root of 27, we want to think which of these list of numbers here, these perfect squares, will go into 27. The only one that really works is 9 times 3, because 9 is a perfect square. And so we take the square root of 9 times the square root of 3. We can break them apart. And the square root of 9 is a 3 because it's a perfect square, and we get 3 square root of 3. Remember, the operation that happens between 3 square root of 3 is the same thing as like when you say 4x. That's a multiplication, and so there's a multiplication here also. Now, if we look at 50, okay, and we want to simplify the square root of 50, we could use 5 and 10, but those won't help us because 5 and 10, neither one of those are listed on this list of perfect squares. We need to find one of the numbers on this list, and so when we go back to that list, 25 times 2 was on, 25 was on that list. So we have square root of 25 times 2, and so we break it apart, square root of 25 times square root of 2, and so that's 5 square root of 2. Okay, so now we've got a little bit bigger number here. We got the square root of 192, and you may not know what the square root of 192 is or what perfect squares go into it. So you first take that number and say, okay, 192. I'm going to go back to this page, and 192 divided by 2 is 96. And so if I look on this list, 96 falls right here between 81 and 100. And so I want to start this list and try. What's 192 divided by 81? And that ends up being some decimal. And I take 192 and divide it by 64, and I work my way this way on that list of numbers. And actually what I get here is I get the number 3. So that means that 192 is 64 times 3. So the square root of 64 times the square root of 3, and so we get 8 square root of 3. You always want to take this list, find where the middle is for the number you're working on, and work your way backwards towards the front, because you want the biggest perfect square, not the smallest, but the biggest. Okay? All right, and so here are a few other problems. This is multiplication. I always like to think of radicals as being prejudiced. They don't mix. And so numbers times numbers and radicals times radicals. And so these are numbers and these are radicals. And so numbers times numbers and radicals times radicals. So I get 12, the square root. Now, I could multiply 6 times 14, but then I'm just going to have to break it back down again. So I'm just going to leave this as 6 times 14. Because if I make that a bigger number, I still got to find out what the factors are of it. And so when I take the 6 and 14, I can now say, well, that's 2 times 3. 14 is 2 times 7. And I can see, oh, look, these two numbers right here, the 2's, can come together and make a perfect square. And so that gives me 4 square root of, and I have these two numbers left, 21. And so this is my perfect square that I was looking for. So 12. This becomes a 2 out here, times 2 times the square root of 21. So I end up with 24 square root of 21. Okay? So if I go over to this other one over here, I want you to remember that simplifying to start always makes the problem easier. Okay, so if I look at this, I can't mess around with this 6, but that 8 right there can simplify. So that'd be 4 times 2, which would bring a 2 out. And so when I go to 2 here, that'd be 12 square root of 2 times 4 square root of 6. Okay, and now I can go back to my multiplication rule. So I got 48 square root of 12. 12 is 4 times 3, so I'll bring out square root of 4, which is 2, and I end up with 96 square root of 3. Okay, And so that is always easier, because if I'd have just multiplied to start, I'd have had to simplify the square root of 48, which is a bigger number. It's still doable, but more factors, bigger numbers. All right, we want to work smarter, not harder. Okay, so I was going to work these problems, but I decided maybe best we'll try those later on. You could work 11 or 12 here if you'd like, and then you could check in class. If you do this one, then you get 30 times the square root of 2. And this one over here, you get this one you get negative 24 square root of 5 if you wanted to practice those. Okay. These are some bigger numbers here. You might want to practice with those and see if you can simplify those. If I put the answer up here, you would know them real quickly. So you might want to pause the video, wait a second, and then check. When you get this one, you'll get 12 square root of 3. And this one, you'll get 22 square root of 2. Okay. All right, so when rationalizing the denominator, it's another name for division of radicals. We're basically not changing the problem any whatsoever. We're only changing what it looks like. So we have these 3 rules. First, you cannot have a radical in the denominator. So if you have a radical in the denominator, you got to work with getting it out of the denominator. Have to have all radicals must be simplified and all fractions must be simplified, or we say reduced. Now, these 2 rules here and here, those should be true every time you work math problems. You should always simplify things completely. All right. Now, before we go into simplifying, let's go over a few basic rules. If I had the fraction 2/5 and I wanted to convert it to have a denominator of 15, I always ask, what would I do to do this? And a lot of people tell me that 2 over 5 times 3 would get me that denominator, but really that only gets me 6 over 5. In reality, in order to really get that to have a denominator of 15, you have to multiply 2 over 5 by 1. So we multiply by 1. But there's so many different versions of 1. In this case here, we want to multiply by 3 over 3. And that gets us 6 over 15. And that is the same thing as this when it's reduced. Remember, when you multiply something by 1, you never really change what it is. You're just changing what it looks like. And so multiplying by 1 doesn't change the problem. It just changes what it looks like. And that's how we convert to different denominators so we can add things that are alike together. That's what we're going to be working on today when we rationalize the denominator. Okay, so if we take these problems here, I have the square root of 2 over square root of 3. This is breaking the first rule, is that we cannot have a radical in the denominator. So we're going to multiply by 1. The version of 1 we want to use here is we want to get the radical denominator, so we want to make that denominator a perfect square. I do that by multiplying the top and the bottom by square root of 3, which is my version of 1 here. When I do that, I get the square root of 6 over the square root of 9. But the square root of 9 is really 3. And so now if I look, I have no radical in the denominator. The square root of 6 can't be simplified. And there's really a 1 in front of the 6. The 1 and the 3 can't be reduced. So that answer is done. I don't have to do anything else. That is a completely rationalize the denominator problem. If we look at number 2, we have a radical in the denominator. We can't have that. So we got to multiply by some version of 1 to get rid of that radical. And to make that a perfect square, I'm going to use the square root of 5 over square root of 5. Now remember, this is a radical and a number. They don't mix. So this is 2 square root of 5 all over the square root of 25. And remember, that's 2 square root of 5 over 5. When you multiply by some version of 1, you should not have a radical in the denominator anymore. If you do, then you messed up when you were working it. Okay, so now let's check. No radical in the denominator. The square root of 5 can't be simplified. The 2 and the 5 cannot be reduced. I'm done. That's it. Okay, now it's time for your favorite ones, the fractions. Now you're looking at this and probably say, oh, I hate fractions. Well, we can make this a lot easier. Since it's a fraction inside a radical, you can break it up to be square root of 3 over square root of 7. And that's actually the exact same thing as what you see here. So those two things are equivalent. Now it's just like the problem we had at the very top. Multiply by one version of 1, and our version of 1 this time was going to be square root of 7 over square root of 7. So that's the square root of 21. Now that's the square root of 49, right? Well, let's just go straight to the 7. Let's kind of cut out that step there and make that a little bit easier. All right, so let's now look. Do we have a radical in the denominator? No. Can we simplify the square root of 21? No. And do we have anything to reduce with the 1 and the 7? No, so that is our answer, and we stick with that. Okay, so we have a few more problems to practice. If you want to pause the video and practice these, that'd be great, and then I'll put the answers up. Okay, so for this one, I don't know what you did, but let's see if you did this. Did you take the square root of 4 first to make that a 2? Remember, always simplify. It makes problems easier. Now I got to multiply by my version of 1. And so I get 2 square root of 7 all over 7, and that's my answer. I'm done. In this one here, there's nothing to simplify, so I multiply by a version of 1. So I got 4 square root of 15 over 5. And that's done because we cannot simplify square root of 15. We cannot simplify the 4 and the 5. We got one more here. Hopefully you multiply by your version of 1, just like I'm going to. So 5 square root of 3 all over 3. Nothing else to be done. That is the final answer. Okay. Now, I keep telling you, simplify first before you work anything. And so here's one of those cases where life could be so much easier if you did. Okay. So if I simplified this to be 8 is 4 times 2 and 18 is 9 times 2, so that would be 2 square root of 2 all over 3 square root of 2 when I simplified each of those. Well, when I get to this, I could cancel both those 2's, and all I have left is 2/3. At the same time, we could have, remember that both of these are radicals, remember that radicals are prejudiced? I could have gone in here and reduced this. Well, 8 divided by 2 is 4. 18 divided by 2 is 9. So I got the square root of 4 over the square root of 9, which when I take those square roots gets me straight to this answer. So there's lots of ways to work that. That is so much easier than multiplying by a version of 1 like square root of 18 or square root of 18. That just makes the numbers too big. This one, number 8, pay attention. They're both perfect squares. We're done. Okay, number 9. Okay. For this one, look for the things that can be done. We want to work smarter, not harder. And so we want to go in here. We cancel this one and this one. So we end up with a 1 and a 3. Okay, so if we cancel those numbers, now all I have left is 2 over the square root of 3. And now I can look at my rules. I can't have a radical in geometry, so multiply top and bottom by square root of 3. And I get 2 square root of 3 all over 3. And now I've got my final answer there. Okay. All right, so you can practice with these for a few minutes, and when you're done practicing with these, you can check your answers. So pause the video and do these 3. Okay, now that you've got them done, this should be 5 over 2. This one should be square root of 3. And this last one should be 2 square root of 6. And so that should wrap it up. If you have any questions, make sure you practice on the worksheets on rationalizing the radicals and have questions when you come back to class next time. And thank you for your time.